Hey everybody, it's Chris with LG Squared, and I want to talk about simplifying high performance. We've been designing high performance homes for more than 10 years now in the Southeast, and helping projects throughout the country and outside of the country to work toward a high performance, a more passive building. As the architect, as a builder, as the HVAC designer, as a consultant, we've been involved on many projects, and we've seen how, many different ways to design your slab, design your walls, design your roof, and build all of them and bring that structure together. And as we're doing it, as we're out in the field with our subcontractors and in the office designing and working with our structural engineers, we're always looking for opportunities to make things more simple, but maintain our structural integrity, performance, architectural beauty, indoor air quality, and overall just a really well-designed, well-built building that's going to last for a really long time. This video is going to be about our slabs on grade. So we've had a slab on grade detail that we will share that we've been using for quite a while that's worked. It's a fully insulated slab. And it's a design that people can understand pretty easily because it meets the code fairly simply. We've had some run-ins with the code officials because they hadn't quite seen it done this way, and they're only used to seeing what's in the code books. So this is we're trying to maintain the integrity of the design and the construction, but simplifying it without compromising any of the integrity. So let's dig in now. Again, it's simplifying high performance, and we're going to talk about the new design we've been working on with our structural engineers, geotech, reviewing the code, talking with manufacturers, engineering, and their building science teams to make sure that all of these products work the same or better than the way we've been using them. So getting into it, this is just a reminder. I want to just make sure that everybody watching this understands that this is a detail that works for our projects, and it works for the soil, the climate, and everything that we're doing on our projects. Wherever our projects are, this can work. But I encourage you, in fact, I would recommend not using this detail for your project exactly the way it's drawn here. Get with your own team, get a geotech, look at the code, make sure you understand your climate, and make sure this detail or some version of it is what you need for your project. So just a good thing to get started on. Make sure you design it for your project. So as I said, we've done we had a slab on grade detail that we've been using for years. This is a project in Western North Carolina. It's off-grid. Three simply shaped structures with this robust slab that we've got here. This is a fully insulated slab. The turn downs are insulated, under the slab is insulated, and it's all insulated with stone wool except for one portion, and I'll show you that in a second. So this is that detail. It's got a turn down, it looks like a beam. It is essentially a grade beam that runs around the perimeter of the structure. This is a version of this project, by the way, because this is all wood frame. That project in Western North Carolina was all steel framing, but it's based on that design. And so we got, as you can see here, we got 8 inches of stone wool on the exterior. That's our slab edge insulation. Then we got our 4 inches of insulation underneath, all the way to the other, throughout the slab. The off-grid project had 8-inch slabs on each of those pads. They were looking for something that really was going to stand the test of time, so we went to that level of design. Then we have this turn down is 22 inches from the top of slab to bottom, and it sits on a continuous layer of EPS, okay, a type 6 EPS. You can do type 4. It also has the right bearing capacity. We go to type 6 because there's a trivial increase in cost, and because we can. This is bore rate treated. And we have this vertical piece. This is also stone wool. This is used as the formwork for our turn down. And I'll show you, we'll show you some of that in a minute. But you can see there you've got 1, 2, 3, 4 surfaces here, all, transitions that we have to deal with on a turn down. So this is something, and you'll see in the pictures here, there's a lot goes into creating these turn downs. You have a lot of trenching. And so here's another example. We did this in Marietta. You can read a whole lot more about in the JLC article I wrote in February of 2020. Go check that out. This is very similar, not as much insulation, but still very robust, good detailing. It breaks down the process and a lot of the materials. This is the formwork for that project in Western North Carolina. You see over here the insulation on the inside. It's holding the inside of that turn down. Then we've got plywood out here with bracing every 24 inches. It's a lot of concrete to hold back. This is the foam board that is treated with borate, and then they used the borate foam EPS as their bracing, until they went to pour it, and we don't do that anymore because that's a bit wasteful. We also don't use foam, but we'll get into that in a second. So this is the interior of the slab this way, that's slab edge going this way. This is where all the gravel is going to go, and then we'll put another layer of stone wool on top. As you see, that's this layer here. This is that vertical piece you're looking at now, and then we'll put this piece in, then our vapor barrier and the slab. So this is them putting our crew putting in the vapor barrier. And there's there were 4 or 5 surfaces there. They had to work a way around with the vapor barrier, and all those corners all had to be nice and folded nicely, and then all the seams taped well, perfectly, so we didn't have any vapor intrusion, but potentially even critter intrusion. So this was, it was tedious work. It was worth it, and this is still a great detail just about anywhere in the world. So it's just a matter of matching your climate, your soil conditions with your reinforcement and your insulation and your budget too. So a real quick look at the code. This is what our code looks like here. 12 inches is our frost line here in Georgia. In our part, most of climate zone 1 through 4 doesn't get deeper than 12 inches. So we typically have to get this turned down down to that 12-inch frost line, because we have this, because it's exposed to the colder temperatures, this gets really cold, and if it's wet, it'll start to heave and start putting pressure on the foundation. This insulation here is to help, insulate the soil below and up to the slab here, and these are required in certain parts of the country. It is, but in climate zones 1 through 4, for the most part, absolutely not required. There is a part of the section of the code that covers where you are required to have horizontal insulation or not. So this is that same detail, just showing how we are below the frost line with our slab, with our turn down. And this is that the frosty soil area that we're trying to protect our slab from. And one of our engineers had a really good analogy of what this turn down is doing for us. And he said it's basically creating a wedge between our frosty soil and our building to prevent any damage to the foundation, to our slab. And so since this is not, freezing temperatures in here, it's not full of water and expanding, assuming you've done all the other designs appropriately and you don't have a high water table. This is all dry and warmer because it's below the building, and out here it's exposed to the elements, and you're getting down to maybe 10 degrees, and that's a big temperature difference between inside and out. And so this area can expand because if it's moist, and that's the whole point. That's one of the main points of getting below the frost line. Just one other thing, some parts of the country require continuous insulation at the slab edge. Here in Georgia, we do not. I'm just pointing that out. We don't need to have this insulation. This is about high performance. It's about passive buildings. It's stopping that heat flow through the concrete, which is one of the most thermally conductive materials that we build with. So we want to insulate that edge and stop that heat loss, which can be up to 10, maybe even 15% of the heat load in a building, depending on the design, on the building and the location. There's a significant benefit to having that slab edge insulation. Let's talk about the perfect wall real quickly. The perfect wall, which is also the perfect floor and also a perfect roof. And then when you tie it all together, you have a perfect enclosure. And what makes it a perfect wall is that it has all of the key control layers, which are considered to be water, air, vapor, and heat. We like to add in there UV as a control layer, fire as a control layer, and aesthetics as a control layer. That's the architect side of me talking there. But we want to control all these, then you have a perfect assembly, which is the wall, roof, and floor, and then you have a perfect enclosure. So I bring this up just before we get into the details of our design for this slab, because it is a perfect floor, and then how we're tying it into the perfect wall in an uninterrupted, continuous way. So this is our slab-on-grade assembly that we're talking about. Now this is just more in the middle of the slab. Generally, this is our sort of our detail that describes the assembly. 8 inches of concrete, 4,000 psi with number 4 is 12 inches on center each way. This is an important part of this design to help simplify it. We've got our vapor barrier, continuous insulation under the slab, minimum 2 inch up to 4 inch. This, in our climate zone, we get down to maybe 40, 50 degrees in our soils, so having a lot of insulation down there doesn't make as much sense as, say, up north where the temperatures get much lower. Then we have our 8 inches of granular fill, and there's a reason we've doubled that as well. And then this is our above grade wall, just kind of showing this because we'll show how this ties in to our slab. In a minute, we got the continuous insulation, cavity insulation as well, and all of our control layers are still right here at the sheathing. Just a quick look back at the original detail before we look at our new slab edge detail. So here it is, 8 inches all the way to the edge. Absolutely no turn down. All the buildings we're working using this slab on are 1 to 2 story. This can go up higher than 2 stories. You have to talk to your structural engineer about the thickness of the slab, the rebar, the soil underneath, the gravel. Everything has to be specified to make it work for 1, 2, 3 stories. But this 8-inch slab goes all the way to the edge as 8 inches, and then we're sitting on stone wool insulation under the entire slab still. No foam anymore. I'm getting rid of that foam. We're using a higher density stone wool right there at the point loads, which is the exterior above grade wall at the perimeter, but anything inside also gets that top rock. It's a load-bearing condition, so the top rock goes underneath, say, a load-bearing wall in the middle of the house. So these specs down here are what you would give to the structural engineer, and they would use that in their calculations, in their design. And the same with this here. This is a comfort board 80. That goes everywhere else that we don't have point loads under the entire slab. The reason we've got 8 inches of gravel underneath all this is to get us down to the frost line. Now, do we really need to get down to the frost line here? We've created our wedge here, right? So we've got our wedge of, the insulation, of course, is insulating the slab edge. We've got our frosty soil here, buffered by insulation and by gravel. We typically do 6. We're just going the extra 2 inches to get it down to that 12-inch frost line. We've got our wedge, we're protected. By doing this entire slab 8 inches, we've eliminated all that trenching and all that origami with the insulation and the vapor barrier, no beams in the middle, and it works, and it simplifies it. Not saying it works everywhere on every project, because every situation, every project is different. So talking about reduction of material, this is a look at one of the projects we did the turn down on in Marietta, and that's the red is that's the turn down, and then the thickened area down the middle for the structural, that's a bearing wall down the middle. So if we take that and calculate the amount of concrete in that slab versus an 8-inch slab, we've got less in the 8-inch slab than we do in the slab with the turn down, so we're saving as much as 16 yards on this project. That's not always the case. Sometimes it's a wash. It's the labor of all the trenching and wrapping the insulation, the vapor barrier, that's the real savings here. Always consider your own climate zones, your design, your soil bearing, building codes, everything. Just make sure that whatever design you come up with, whether it's this one, similar to this one, or something different and innovative and something against what you normally see, whatever it is, just make sure it works, and you got to get the right people involved. Of course, you can call us. We can help you anywhere in the country, outside of the country. We can help with the design of these structures since we've had experience with them. Later, we're going to show pictures from the project as we build these, and we'll show how the execution played out. So you can find out more on these projects that I mentioned during here, the Western North Carolina project, one in Marietta, Georgia, and on our YouTube channel, there's more information about these slabs, how we installed, what products we used, and the process that we went through, both design and in construction. We talk about how we measured soil bearing capacity. This one down here in the corner is it's an interesting one. It's an old school way of actually cooking the dirt. That's fun. This has been Chris with LG Squared, and we'll see you next time.